is given to you, and that cylinder is just dipped in a liquid. Okay, so let's say if this is the cylinder, okay, and this cylinder is dipped in some liquid, right? And let's say this is the level of water, right? This is the level of water in which the cylinder is dipped, right? Now it's given that the cylinder of uniform cross section area A. So here you can see the cross section area, this is given to you, and that is equal to capital A. These are the data given to you into the question, right? And it has a mass m, and it has also some mass, and mass of this cylinder is m, right? Now it floats with its axis vertical in a liquid of density d. So the density of this liquid, density of this liquid is nothing but d, right? D is the density, m is the mass of cylinder, and A is the area of cross section, right? So I'm writing CS area, cross sectional area. That means this one, which is shown in shaded, right? The circular part of the cylinder, right? Now a cylinder of uniform area of cross section A has a mass of m and floats with its axis vertical in a liquid of density d. So the axis of this cylinder, when you consider this as vertical, right, this is the vertical axis through which the cylinder is just floating. Okay, now here it's given that if it is pressed down slightly and released, so from here if you apply some pressure, just apply some force, right, and so let's just force down slightly and released, then what you will do, you can see this cylinder is going down, right? When this goes down, the cylinder is immersed in the liquid, is acted upon by two forces. So two forces will be acting on the cylinder in that condition. What are those two forces? The first force, you know, is due to its weight, and that is nothing but equal to mg, right? So the first force, the two forces, number one is mg, its weight, right? Now after this, the force of buoyancy, if you remember the Archimedes principle, if the cylinder is pushed in a liquid, okay, or of any density, then the cylinder tends to come upward. If you are pressing from top, it will dip for a moment, right? But when you leave it, when you just stop applying this pressure, you can see this cylinder will again try to move upward. Okay, this is the force of buoyancy. And what is this force of buoyancy? If you remember the Archimedes principle, if you remember it, then what will happen? The magnitude of this magnitude of this restoring force, right? It depends upon the level of liquid which is dipped into the water. So here you can see this section of liquid is dipped into the water, right? It all depends upon this section, that is the section which is dipped is directly proportional for the second force. And what is that second force? That is force of buoyancy, right? So this buoyant force is responsible to restore the position of the cylinder to its original position, that is mean position. So if you remember the SHM for any pendulum or any mass, so that mass was moving from its mean position to left, then coming to its mean position, then goes to right, then again coming to its mean position. So this oscillation was happening, right? So such oscillation will you can observe over here also, because it will be in a vertical direction. Because if the force is applied through the top, it will go down. So this will be the section of graph. If we remember, it will be like this, right? Then when it is released, due to this dipped section, the force of buoyancy will be acting upon, and then this will push this cylinder upward. Okay, and this is nothing but the force of buoyancy. Okay, so this will be represented by this graph. So you can see two graphs will be the SHM graph you can be easily depicted over here. Okay, this is by apply due to the applied force due to, as the cylinder is going down, and this is due to the buoyancy force, right? Now I will not go much deeper into it. Let us solve the question. Okay. So the two forces which are acting on the cylinder is one is mg, that is its weight, and second is the force of buoyancy, right? Now suppose the cylinder is immersed into the liquid x centimeter deeper, right? This is the original position, and let's say it is just dipped over here by the applied force by x centimeter, x, right? So I'm writing it. If x centimeter deep or deeper, this is happening for the cylinder only, this cylinder. So if this is applied just pressed x centimeter deeper from its mean position, then you can say the force of buoyancy and mg will be the two forces acting upon it, and the restoring force is nothing but is equal to vdg, if you remember, and volume is nothing but area multiplied with this x, that is height. So this will give you the volume v, this is the value of v, right, into d is the density of the liquid which is given to you, right, and multiplied with g is nothing but the acceleration due to gravity, right? Now this restoring force, that is, this is a force, and this can be simply equated with F equal to ma, right? And this will be equal to minus ax, that is the volume, into d into g, right? Hi Mimilu. So here you can see this is nothing but ma. So here you can see the acceleration can be a, the value of a can be written as minus a Here you can see A is a value, D is a value, and G is also a value. So let us write it. Minus A, D, G divided by this M will be going to the RHS M, right? Into multiplied with what? Multiplied with this X, right? So here you can see this is a constant. This is a constant, right? This is a constant. So we can say that acceleration is directly proportional to the negative x. Why negative x? Negative sign indicates, this negative sign indicates a and x are into the opposite direction, right? You're putting it x, the displacement is happening over here. When you press it from the top, displacement will be happening over here, right? And cylinder is going x centimeter deeper. So, and the buoyancy force will apply into the opposite direction. Force of buoyancy will be applied from this direction, and this will try to, this is acting against the direction of velocity, direction of displacement. So that's why this negative sign is there, right? Now, now quickly, we have almost solved 50% of our question. Let us go to the second point. The second point is that in a SHM, we know the acceleration of any body executing simple harmonic motion SHM is given by A, where A is the acceleration and its value is minus omega square x. If you remember, I am using this formula, right? Minus omega square x. Now you can see the above is also acceleration, and here it's also acceleration. So why not equate it? Just equate it. When you equate it, on equating, what you will find? Hello Leonard, hello. When you just equate it, this value will be equal to minus omega square x, right? So this will be equal to, I'm writing, minus ADG by M multiplied by this x, right? So here what we can see, here we can see that this x and this x can be cancelled out. This minus and this minus will be cancelled out, right? And here we have the value of omega, and the value of omega is coming as, when you apply root on both these sides, the value of, on the LHS we have omega, the angular velocity, which is equal to root over of ADG divided by M, right? So this will be the omega. Now the period of oscillation, you know, time period T, that is period of oscillation, is given by T is equal to 2 pi by omega, right? Hi Leonard. Oh, thank you so much for your comments. You are saying me smart. No, you all are equally smart, Leonard. So because you are just giving some time to understand, and just and thank you for that. I feel thank you. So just let me complete the question. T will be equal to 2 pi by omega, right? We can discuss later on. Yeah. Thank you. So T will be equal to 2 pi by omega. We know the value of omega now. So this will be equal to nothing but 2 pi divided by this value of omega. So just put it over here into the denominator. So this will be root over ADG divided by m, under the root adg divided by m, right? Now the value of time period of oscillation, right? The value of time period of oscillation is calculated, right? That is equal to, we can write, if m will be going upward, so this will be coming as 2 pi and then root over of m will be going up, m by a d g. So this will be the time period of oscillation of a cylinder which is half dipped or which is dipped into a liquid, right? Which is dipped into a liquid, and the time period of oscillation of that cylinder is 2 pi root over of m by adg, right? So students, here we can see the length of the cylinder immersed into the liquid was L, right? And at equilibrium. So we understood that since the cylinder was dipped into the liquid, and if it is the forces which will be acting upon it is that its weight, this one, this is number one force, and number two is the, just recall the Archimedes principle, okay? That is, the force of buoyancy will be acting because if it due to weight it is going downward, and the reverse of that force will be because anybody when pressed or by some external force or by its weight, it will try to restore its original position. This will happen like this, right? The due to the weights going downward into the water, and due to the force of buoyancy, this part will be applied, and weight is given by the positive half here. So this will show that SHM will happen. That means this cylinder due to its weights going down, right, going down here, and again due to the Archimedes principle, the force of buoyancy, the second force, it will try to retain its original position. So here you can see the cylinder will try to execute the SHM, right? I have to go. Okay, I will see you tomorrow. Can you shout me out tomorrow? Sure, Leonard. Why not? Thank you so much for being connected. So hope these are the two forces which will bring you this cylinder in a motion of SHM, simple harmonic motion, right? Which I explained to you how the things are happening, right? So if X is the displacement, if X, bye bye Leonard, thank you. So if X is the displacement, then we can see for this X, you can see this X, I'm saying for this X displacement, when it goes more deeper into the water due to its weight, this section, right? I'm saying for this section, which is equal to x centimeter. So if x centimeter deeper, the cylinder, I'm always saying for cylinder, if cylinder is going x centimeter deeper into the water, what will happen into the liquid? The restoring force will be equal to minus VDG, which is equal, where V is volume, area into x. So minus AX HDG will be the restoring force, and the force is, the formula F equal to MA. Just put it over here. We equated it and we get the value of A as minus ADG divided by M into X, because M will be going from LHS to the RHS. And the for a simple harmonic motion, the acceleration of any body is given as minus omega square x, right? Just equate this with this acceleration because both are accelerations, right? So when you equate it, and one more thing, you have seen this negative sign. Negative sign indicates acceleration A and x are into the opposite direction. So that's why this negative. And from the formula A equal to of an SHM, acceleration of a body executing simple harmonic motion is given by, that acceleration is given by minus omega square x. So we have equated is this minus omega square x is equal to this value of A which we have calculated. Minus minus cancelled, x cancelled, taking a square root on both the sides, you get the value of omega, the angular velocity as root over a dz by m, right? And the time period of oscillation was required to be calculated, which is equal to 2 pi by omega, whether it's simple pendulum or any mass executing SHM. So here cylinder is executing SHM. We'll applying this formula, T equal to 2 pi by omega, the time period of oscillation. Putting up the value of omega, what we have calculated, this one, omega at ADZ by M. Just put up this value over here, right? So we get the time period of oscillation T as equal to 2 pi root over M by ADZ. Sir, okay, I hope you find the solution. Okay, thank you so much for watching. So let me take the question. Geo TV. Oh my god. Hello, Geo TV. Sir, which grade is this? This is a question. You can this such type of questions can come into the JE. Okay, such type of questions will come into the JE. But we are just using the developing the concept of SHM, the Archimedes principle, the force of buoyancy. So this is a basic physics concept. Okay, so which can be used into different multiple choice or subjective or objective questions. So this will be from plus 2, okay, plus 2 standard, and even we can say for competitive examinations this will help you, right? That's why I don't understand anything, I'm in 10th. Oh, no, it's nothing like that. You need to start your preparation definitely from 10th, so you are in the right class. Even prior to that you can have started, but there is no late. Okay, it's never late, just start. Okay, and I have not explained anything which you have not learned earlier. These things must you have Archimedes principle, and this you must have been learned in class 9, right? So these concepts have been just simply inserted over here. Okay, so such questions are coming into the JE just to find the time period of oscillation of a vertical cylinder dipped into the liquid vertically. Okay, so this is the condition. So how the things and different concepts are correlated, you can see. So just think like a layman that how what are the forces acting over here, what are the physical components acting over here into the cylinder. So there is nothing additional. The basic concepts were stitched together. So how any question is solved, I am trying to explain. So here we did the same, right? So you can understand it. Though you are in class 10, it's not very tough. Okay, it's very easy, very easy. That's why I try to give time with you students. Just be connected and with this. But sir, first gotta know the basic concept to solve this. Yes, sure. So the basic concepts, yes, the basic formulas you need to remember. Okay. So what are the basic formulas which I used over here? Weight is equal to mg, right? The Archimedes principle, the force of buoyancy, that is equal to AXDG, right? This is the force of buoyancy given by Archimedes. So A into X is not nothing but area of cross section into length. This is volume, VdZ. So just remember this formula, right? Weight equal to mg. This is formula number 2, and T equal to 2 pi by omega here. So I think you already remember this because we are learning this from very class 6 and 7. So you also remember this. So total 3, and for simple harmonic motion, acceleration equal to minus omega square x. So it will come into class 11, don't worry. But yes, only 4 concepts or 4 formulas we have used and just stitch the things together, nothing else, right? So I think it is now understandable, and let me know for any doubt or any further query. Otherwise, we can wind up today's session. Isn't the formula where the water displaced has a relationship with the force? Yes, exactly. The water displaced was a volume with a displacement of x will be giving a force of ax dg, right? So this is the relationship with force. This is the force. This is the restoring force. because when the cylinder is going downward, the water is also pushing it upward. Cylinder is going downward due to its weight, this weight. And when the cylinder is going upward, this is due to the force of buoyancy. So you are right. Since you are right, you are saying that the formula where the water displaced has a relationship with force. Yes, this is happening. You can see this is the x, because the water is dipped more to x. This is the displacement here. X centimeter is the cylinder is more dipped by x centimeter, and how it is dipped due to its weight. But when it dipped and when it remain into the dipped position, it will not remain into the dipped position, but the Archimedes principle, the force of buoyancy will be acting upon it, and that's why it will push cylinder upward towards the surface of the water. So that's why you can see this simple harmonic motion will happen. So that's why I drawn this graph, how the things are happening here, going left, then crest and trough, you can see. Okay, so one is due to acting due to the up positive graph is due to the mg, and here the downward graph is due to the force of buoyancy. So you can see why I have explained this, because this body will be executing SHM. This body will be executing SHM, that is simple harmonic motion. So how the different conditions are there, how a SHM is can happen when a cylinder dipped in water, this question was based upon that. Okay. ADG, what they are kind forgot the concept. Force applied by the mass which is dipped inside water is equal to VdG. V is area into displacement. So you can see this is, if this is the area of cross section A and X, A into X will be giving you a little volume of the displaced solid. Okay, so this is volume into density of the water into G. G is the acceleration due to gravity. Right, GOTV? So, students, I think we have already discussed all the concept in details, and I hope the session for today will be useful to you. Thank you so much for watching. Take care. Be connected. Bye bye.